All right. Welcome back. I will now start sharing my screen again. It should be this one. It's okay. All right. So now we covered these two exercises, and we're going to make an assembly design. There is again one exercise which you definitely need to fulfill, and that's the assembly design. And then one which is more optional, which is the, let me scroll through it, the assembly of the with inverse kinematics. So, okay, let's just start at page 21 with the assembly design. For this exercise, you will again need the 24/7 folder. So I will just launch a new drawing, but not because I need the new drawing, because I need the panel of 24/7. So what you can do is when you have the, when you see the inside BricsCAD mechanical training V21 on the partner area, you can see the assembly design part, and you can right click on this entire folder and download it all in once. If you already had downloaded, you don't have to do it, of course, again, because it will overwrite the copies you already had if you worked on it locally already. So I now downloaded just to have the fresh state for sure. And then again, if you don't know where something is located, it will be, if you download it through the panel, it will be probably somewhere in documents Brics 24/7, but as explained in the training manual, you can go to settings and then see where it says what pod it says with cloud download pod. And in this pod, your entire structure of 24/7 will be copied locally whenever you have downloaded that part. So that's that. Then now we will open the engine assembly file. So you see also that the extra steps are mentioned here, but you can just double click on the drawing to open it, and you see it here. Now, the first thing we need to do, is hide a, or is make a bill of materials, sorry. So for that, we will go to a layout tab. And there you will see that there is already a viewport nicely put on your sheet, but you can of course move it with either a manipulator, for example, by long clicking or by selecting the manipulator, or either by the regular move command. And then it's just this is not necessary, but just to show you that you can also, of course, change the location of this viewport. You can even resize it, of course. And then we want a bill of materials. For that, you can go to the annotate tab. Yes, and then we have there the bill of materials. Inside the assembly subcategory, you have bill of materials. If you press that, the BM bill of materials BOM command will open, and you can use either top level or bottom level. For this, make sure that your command line is open, because in BricsCAD V21, you can press actually the sub options easily and you don't have to type them in. Of course, if you type them in, it's the T for top level and the B for bottom level. But if your command line is open, you can actually just click it, which is very useful. And so I want to add a top level one. For example, here. And I want to reuse that command again, so I can just press enter as well. And I can also choose bottom level now once. The difference between the two will get clearer and in the rest of the exercise as we progress. But in a sense, this is showing you the lowest level, like on every part level, no matter how deep it is nested, they show up here, like the bottom elements. And this is just showing you the top level of the assembly. So not, for example, the sub bolts. If you have, it only shows the bigger parts in the assembly, let's say. So that's the bill of materials in a very short notice. If you want to know way more about this, you will probably hear about a advanced training as well in the near future. And there we will dig deeper into how to customize this bill of materials with the bill of materials panel, because you also have a bill of materials panel here. And maybe we touch it briefly further on tomorrow, but in any case, the easiest thing to do is just use the command BM bomb, and then you can choose between top, bottom, or hierarchy, and then you can insert it already on the sheet. Now we will return back to the model tab. So remember that you have the tabs here at the bottom. And we will hide this element. So you can do that by hovering over the orange element and clicking hide. And then you will see only the real mechanism of the shaft remaining, or of the engine remaining. And then we need to BM insert a element. We do that by typing BM insert or by finding the icon in the quad. And then we want to go again to where we already were. So that is in documents, BricsCAD 24/7, partner area, sales and training tools, mechanical training, V21. And then we have the assembly design. And there we choose the piston assembly to get an extra piston in our drawing. And we just place it somewhere in front. Doesn't matter too much where yet. And then you can do that again. But now this time you won't have to navigate to the folder anymore. It will normally still be open. And you can just choose also the connection rod assembly, and do the same with this one. You just insert it somewhere in your drawing. And we are at step 5, and this is a bit, it's not every step of the way is explained here, but I will walk you through it, and you will you can have the recording of this part afterwards. So what we will do is use constraints, and there are already a fair amount of constraints. If you open the mechanical tab, there are already some constraints, and we will use these constraints both to place the elements next as to use them actually to to just drive or to work together with the rest of this assembly. So the first thing we want to do is make these two holes. So this hole here, this opening, we want to have it coincidence with this bar, because it needs to fit over that. So we go to the assembly tab or to the solid tab. In the solid tab, I think that's what we used before, so maybe you know better where it is there. So you can go to Concentric. Then remember what you, if there are no other constraints that are already attached and in play that can prevent this movement from happening, generally what you click first will stay in place, and what you click second will move to that location. So as you can see, they are not aligned right now. If I click, oh no, it was the other way around. I always get confused. Sorry. So what you click first will move to what you click second, apparently. Sorry. And then you see that now they are actually coincident. So that's the first step of this assembly. Then we can also make it coincidence. But it not always matters too much what stays in place, but so wait, now I need to do it correctly. So the second one stays in place, I said. But it's not 100%. Yeah, so the second one stays in place. Yes. And then it moves. If coincidence means that they two planes fall on top of each other. So the plane of this inner surface here, the red one, fell at the same location as the gray one. So that's what we did here. And now we, of course, need to place it onto this rod still, onto this, how do you say that? I forgot the word. Yeah, the shaft, sorry. Yeah. And then we want to, again, use a concentric constraint to put this in this location. So we put this one onto this one, yes, and then we have it already again in the same axis. And then we still need to do a coincidence again, this time from this phase, from the one that doesn't stay in place. Well, if something in this assembly is fixed, it actually doesn't matter, because then that will prevail over just the order in which you choose things. So since this assembly is fixed by a certain plane, I think, don't see it right now, but it's fixed in any case. It doesn't matter too much, so you can actually be just quite intuitive about it. So you press coincidence between this phase and this phase, and then it moves there, but you see that it's not rotated yet in the correct way. What we can do now is again use a constraint, this time a parallel constraint. So we want to use this plane because we want to have it parallel to this plane, and or even coincidence, no, parallel. Yeah. And if we do that for both this phase and this phase being parallel, and this phase and this phase being parallel, then you will end up with the correct position for the piston. So let me do that. So again, I choose the parallel here. No, not again, but now I choose the parallel. Then I press the two faces, and you see actually that it already, the head rotated around the shaft, because these two were already constrained. So it's actually already taking into account the previous constraints we put there. And now we can put the final one so far, and that is again a parallel one. This time on this, yeah, I don't know how you call that, this face of the rod, and then on this one, and then you see it moves in place, and it looks good now. So that is how you place this piston and rod, or how do you call them, in place. I'm no mechanical engineer, so I'm not 100% sure of all the names, but other than that, I think you got the point. Now we see that actually you can save this drawing, and you see that here the bolts, they are not in place yet. So we will change that. So how do we do that? We open this drawing. So you could use open just, but you can also go to, if you collapse the constraints with the minus icon in front of constraints, you can actually go to the connecting rod assembly, which is one of the connecting rod assemblies. And you can right click and press open from here in the mechanical browser as well. Is useful sometimes, but you can also do it through the core. Then you can open it. And we will now place some bolts with our library panel, which has a quite large standard parts part, yeah, and or folder. And we will search for a specific bolt, namely the ISO 4017 hex head, and then a certain size of it. So what you can do is actually just type in the 4017, and then you can drag it in. The properties will open so that you can easily change the properties. And here in the part number, we want to specifically select a different part, namely the M10 times 1.5 times 40. So we scroll up to the M10, 1.5, 40. And then you will see, yeah, the size changed. Now we want to insert this multiple times. So what we do is we select multiple from the options, or type U to select the sub option, so that you will be able to place it multiple times. Then we want to place it on this surface. Again, with the dynamic UCS, you can actually shift lock this and it becomes blue. So just press shift once. And then with, if your eSnap has the center snap on, you can actually press the center of this hole as well. And that's then the first one we insert. And now you see I can place further, and I can do the similar thing. Well, my face is still locked, so I don't have to do that again. If you would want to unlock, you just shift again. And then you select the center there as well. And then you have the two bolts in place. So now I save the file. Very important step, because otherwise BricsCAD doesn't know something changed of this file. And since these elements in the mechanical browser, we return to the engine. Since these have like this little green arrow next to them, it means that they are external. They're actually referring to that other file, namely the connection rod assembly that we just changed. That makes that we can just update it with a right click on the connection rod again. Now this time we can choose update. And before I do that, I will zoom in. So we didn't have any bolts here. If I update, the bolts will of course arrive. And the nuts, yeah, we didn't add those right now. Yeah, you could also add some add that if you would want that. But now we are at step 12, and we will add some more components, namely roll bearing, or I don't know how you call that exactly, but I think it's called something like that. And you search for in the library for this term BBRG30. It's in the notes of the training manual as well. And you again do the same thing. You drag and drop it, or you click it, and you change the size to 40 millimeters. And then you can already place them in the correct face, let's say, by shift locking this face and then just putting it somewhere. And oh yeah, you could have done that multiple times, but of course I forgot this now. So you can just use the copy command and put an extra one at the back of our assembly. And then we do something similar like we did before. We first make a concentric constraint, namely we use this face, and then it moves already in place like that. And then we can use one of these, we can use this middle face to align with this, for example, with a coincidence constraint. So you select this face and then the coincidence constraint, and then it moves in place. And you can do the same for the back. So like this face, inner of the roll bearing, and then the coincidence constraint for this one and this one. All right, so that looks good now, our assembly, and we can actually switch to the layout tab. And if we zoom in, we see that it updated the drawing, and it also updated the bolts. Like before I didn't have these bolts in here. Now I do have them. Apparently it's not updated entirely yet because my rollers are not there yet. So if you want to update, be sure that it's updated. You can call the command bm update. And then you can select entities to update, for example, this, or just the entire model. And then everything gets updated. And you see here that the bearings are also in the list right now, and also in the top level. So in the top level, that was a part which we put in the top level, not nested, let's say. And then it comes here as well. And then it, of course, also comes at the bottom level because there is no nesting further. So this is also bottom level, but here you see that the bolts, the ISO bolts, they are actually only visible in the bottom level bill of materials. And then we're almost finished, I believe. The only thing which we want to do now is visualize what we actually did during this exercise. And we can do that by rotating the shaft. So you can do that by clicking on it, like a little longer click than usual, just a normal left click. And then you can choose the rotation direction according to the axis, or you could straight away use DM rotate, but I will show that in a minute. So I will first do it with this. And if you now see, this is actually giving you, now it's going in increments, but it's giving you a preview of how this assembly works together in a kinematic way, kind of. So that's pretty cool. You can do the same by using DM rotate, and that you will find here in the model tab, rotate. Then you need to pick a rotation axis, and you can select the Y axis for this one. And then you will have the same thing as you would have with the manipulator, that you can preview this. And to improve visual representation, you can tune some settings. Drag mode height is 1 and drag mode interrupt is 0. Not needed, but just for you to know. And that's it. Then I will give the word to Frederick to show us the last exercise quickly, for if you have extra time during the breakout sessions, you can also try that one. So I will stop sharing my screen and give the word to Frederick again.
Okay, thank you, Fleur. I should be sharing my screen now, and
yes,
it is visible. Okay, so the first exercise, the engine block, is what I wanted to focus on for this breakout session. I will go through this exercise fairly quickly. It is mainly meant as a volume training on placing these different constraints. So similarly to the engine block, I want you to download the entire folder here, the folder 6 assembly inverse kinematics. Download this folder by right-clicking it, and then you will get the files downloaded to your folder system. To ensure again where it is, you can find the cloud download path in the settings window under program options and BricsCAD 24/7. You can easily copy this and paste it into your browser to find it easily. And then we want to import the first part of the industrial robots in the exercise. If you do not have the communicator installed, you can, of course, upload or open the step where it has already been imported. I guess I can show you that as well. So this step 1, you can open. If not, or if you want to import it here again, you can click the BricsCAD logo in the top left and choose the import option. And here you can find, you will have to locate where you saved it and downloaded it, and then you can open it from here. Oh, that was the wrong one. So I will just open up the one from the step for simplicity. So here you can see the imported file. You can notice some different things, like, for example, here there are several faces, more faces than needed on the part and such. And to simplify some of the geometry on this file, we can use the dm simplify command for the entire model. And you will see that the geometry and topology has been simplified, and now this is one solid surface reaching from this fillet around to the other fillets, just to show you that it actually did something. Now, this is just an imported simple collection of different solids, and I want to then later constrain it back together. So I will then manually just move these different things around with either the move commands like we used earlier, or with the manipulator by clicking and holding a little bit longer than normal. And after doing this, we want to place some constraints and possibly change the colors so that we can identify them a bit easier. So now we can easily visualize how many different parts are in here. Also, I would like to form them as different components, but first, to more easily visualize it still, I can change the colors of these different things, for example, to black on the bottom one, for example, pink here, green on the hands, or green on this one, I mean, like it is in the handout. Yellow on this one. This one as blue, and so on. And now I can use the command bm form to classify these different parts as components. I can type this in the bm form command, and from here I can select what part I want to form. I can select this one, hit enter, and I can then form it as a local component in the command line dialog. I can simply select it, or I can type L. I will just hit enter to select the default insertion point, and I can name it base, and you will see it appear in the mechanical browser. I will do the same for the other parts. just repeating it with local parts and calling this one shoulder, or that should be platform actually. And for the remaining parts as well. And as I'm doing this, you will be able to see that the mechanical browser is being filled up with parts and components. And these we will then later work on putting together. It is fairly straightforward and it is not too difficult to do this. So it is just meant as volume training, as I mentioned earlier, to get you used to working with the different constraints and forming components and creating an assembly structure. Now that we have classified everything, we can see the different parts in the mechanical browser. And from here, we can then apply the, for example, DM fix to the base platform. And you can see it appear in the mechanical browser. We can create a concentric constraint between this face here and this circular face, so they share the same center, and place a coincident constraint between the surfaces, similarly to the engine block. And you will be able to use the concentric and coincident constraints on the other parts of the assembly as well. Now we are basically just reassembling the same part that we imported, but of course now it will all be attached instead of being separated. As you can see, you have to be a little bit strategic maybe with where you place the different constraints, but it should be easy enough to figure out or to see where you can apply the constraints. The concentric constraint should of course be applied on circular surfaces, and the coincident should be placed on flat surfaces. Such as this. And now you can see we have a collection of different constraints in the mechanical browser. If I try to rotate this part, then we should see that the other parts rotate with it as well. So that means that my assembly is attached together. We can also choose to insert more parts onto this assembly. You will find that here. So I will open or select the insert component option, find my BricsCAD partner area. I will have to go to there. Find my saved location of the folder, and through the folder system. And here I can insert a car door, for example. This has this conveniently placed hole here, so it is more easy to insert it to the assembly. I can apply another concentric constraint and a coincident constraint on this. As such. Now, let's say I want to modify the hand of this assembly a little bit. I can then go to the hand in the mechanical browser. I listed it as a local component earlier, but I will switch it to external by selecting it and right-clicking it. By switching it to external, I can choose where I want to save it. I will save it just on my desktop, for example. And then I can open this external reference. I can then make any modifications I want. For example, extrude this part a little bit further. I can then save this part again, similarly to what was done in the engine assembly. I can then update my assembly here, and you can see the arm is updated to account for the changes I made in the part. So then you can also try to move around this door, for example, and see how your assembly will move and adjust to the different constraints that you placed and such. So prioritize the engine assembly since we are a bit short on time. And if you are done early, you can give this exercise a try. And I think it's time to move to the breakout rooms. Okay, everyone, welcome back to the main session. I would like to, this concludes the content for the training of today. I would like to thank everyone for attending today, and remember that the next training session will start tomorrow at the same time as we started today. Then tomorrow we will continue the training material and cover more of the parametric capabilities, drawing generation, bill of materials, and sheet metal features. You can also join tomorrow with the same link as you can see in the chat and at the same time. So thank you everyone for joining. See you tomorrow.
Thank you.